Welcome back to Cloud 42. I'm James. On Christmas Eve, I posted a video about moving my new surface grinder into the shop and getting it wired up and ready to run. It's still sitting over there in the corner right where we left it, and we're finally getting back to that project today. I was able to solve the electrical problem we were having with the phase monitor, but there are a couple of other issues that need attention. Most notably, the wood riser blocks that I have it sitting on are letting me down. Literally. In the previous video, when we installed the grinder, we opened up the electrical box here and installed a phase monitor. Now, the phase monitor is wired into the 3 power input phases so that it can monitor all 3 legs and make sure that 3-phase power is present before it allows the grinder to be turned on. This is to prevent damage to the 3-phase motor that could occur if we turn it on with only a single phase present. When I first installed this, I used a phase monitor that I purchased from Automation Direct, and if you remember from that video, we did have a problem in that when I turned the grinding spindle on, it immediately cut power to everything. The problem turned out to be that the phase monitor was too sensitive, it was too fast acting. As you can see here in the specification, it cuts power if it loses a phase for more than 100 milliseconds. And I'm pretty sure that that's just not suitable for a phase converter. When the load from the spindle switches in, it lowers the voltage on that 3rd generated leg enough that it was triggering the phase monitor and cutting the power. The solution was to buy a different phase monitor. This one is sold by American Rotary, and it is designed specifically to work on their rotary phase converters. If you were to open the box, you would discover that it has essentially the same electronics. In fact, I think it is actually the same PCB, but it has bespoke programming on it, and this one will run for a full 7 seconds before it reports phase loss, which is perfect to give the spindle time to spin up and the rotary phase converter time to stabilize. If I plug this back in here, you can see that the red light is flashing. This means that we have a phase loss. That's because the 2 legs of the single phase 240 are passing through the rotary phase converter, but there is no 3rd leg since it's not switched on, and it will not let me power on the grinder. Let me turn on the rotary phase converter, and you can see that's now flashing green, waiting for power to stabilize, and once the timer has expired, it switches on. And now we can turn on the grinder because all 3 phases are present and stable. You can hear that little relay R1 just came on, and now I can turn on the spindle. And there's no problem at all with the spindle coming up to speed. With the other phase monitor, it would just start to spin, and then the power would cut out. But this is working great. Now I would like to test and make sure that if I have a phase loss in operation, it will actually shut off, but I don't want to do that with my expensive spindle motor. So I will switch on the contactor for the vacuum, which I don't have connected. Turn off the phase converter, and after 7 seconds, or something like that, the contactor shuts off. So that's working. Let me hit the e-stop switch so we don't have any surprises later, and move on to something else. When I installed this grinder in the previous video, I set it on these wood blocks, and that was partially a convenience so that we could get a pallet jack underneath the grinder, but I decided to leave them there because I'm 6 feet or 183 centimeters tall, and I need the extra height to be able to operate the controls without bending over. These blocks give me an extra 3.5 inches of height versus if I had the machine sitting directly on the concrete, and that is just enough to make it comfortable for me to use. There are 3 feet here, there are 2 in the front, and there is 1 in the back, and the entire grinder weighs about 1,500 pounds, but most of the weight is on the foot in the back. Because that's under the column, that's where most of the weight of the grinder is sitting, and it makes the whole machine try to tilt backwards, and the only thing resisting it is that wooden block. Now these feet have little kind of cleats on the bottom of them, so there's not a lot of support area, and unfortunately the one in the back is settling into that block, and it is noticeable. I leveled the machine when I put it in, and it will not stay. No matter how many times I level it, when I come back, that back foot has sunk further and the machine has tilted back. I'm pretty sure it's not the concrete slab that's moving. I mean, it's possible. The concrete slab in this garage is not great, and it has moved since I moved into the house 19 years ago, but I don't think that's what's happening here. I think we just need to find something better than wood to put under the feet. You can see here when I stand next to the machine that with the blocks under it, it is just about the right height for me. Let me crank the table out here. I have a camera mounted here so that you can see the measurements, and I've got my stair at number 98 precision level. I'll just set this here, and you can see that left to right, we're really pretty close. I'm off by about, probably a third of a graduation, and that amounts to about 2 thou per foot. So that's plenty. There's no need for this to be any more precise than that. But if I switch it around the other direction, so we're measuring front to back, you can see we are off by a mile. I had this perfectly centered after I installed the machine, but it just keeps sinking. You can see I have to lift the back of the level quite a bit to get the bubble centered. So we're going to have to do something about that. The whole machine just keeps tilting back. I keep leveling it. It's not doing any good. So we need a solid foot under the back. In fact, we need solid feet under all 3 corners of the machine. So we're going to make something for that today. And we're going to make them a little wider than it seems like might be necessary because we do get earthquakes around here, little ones, and I don't want this thing falling off the feet. The material I'm going to use for the feet is 5-inch aluminum round. And yes, this is quite a bit more material than I need. I just went ahead and bought the entire stick that they had at my local metal supplier because usual. I'll just measure here a little more than the 3.5 inches I want for the finished length of the foot, and we'll just cut it off. Now I am using my Evolution cold cut saw for this. I do have a 4x6 bandsaw, but in case it's not totally clear, 5 inches is more than 4 inches, and the saw won't really do it in one pass. In fact, with the blade I have on it, it doesn't really like the really thick materials like this. I really need a coarser blade for that. Can't be too safe with this. It does throw chips everywhere, and it is very, very loud. I do have the aluminum specific blade in here. The saw comes with a blade for steel, but I bought the separate blade that has the correct geometry for cutting aluminum. I do have the saw on the floor over here because this thing throws chips everywhere. And if I have it here on the floor close to the door, it sort of helps to contain it. I think there's nothing left to do but just make the cut. Now this is more than this saw is really intended to cut. It's really intended more for hollow tubing and extruded sections. But as you can see, it will do it. I'm trying to figure out how much pressure I want on it. If I go lightly, it's kind of bucking a little bit because the blade's not perfectly centered. If I press harder, it runs smoother, but you can really hear it bogging down. And that was too much. I did not stop that. It stopped on its own. And it is not restarting. Lovely. And it's also jammed in the cut. Get some WD-40 here and lubricate it and see if we can get the blade out of there. I don't want to try to start it again from a dead stop once we figure out why it's not running and get it fixed. So I'm going to try to get the blade out of here first. And yeah, it's jammed in there pretty good. There we go. Switch is not working. It's not powering on. I don't see a breaker anywhere on the motor. And in fact, the motor is not even warm. So I'm not really sure what's going on. Let me go check my extension cord. And yeah, it was the breaker on the extension cord. I have it plugged in directly now, and we can continue. We'll go a little bit lighter here and not put quite so much down pressure on it. And it should be fine. Yeah, the saw is not really intended for this, but we're going to make it work. And there we go. It's actually a very smooth cut. You can see we did leave some paint on there from the saw blade, but it's pretty square, and there's not a lot of machining marks in the end of that thing. I think that's going to turn out nice and easily. Let me go ahead and mark and cut 2 more of these. And hopefully we won't jam the blade. I'll just take it nice and easy. I really don't like the feel of the saw bucking. You can see it kind of skittering around on the ground a little bit. I'll try some lubrication here with WD-40. All it really is doing is making smoke. It's not really doing much. I'll go ahead and get 2 more of these cut off though, and then we should be ready to take them over to the lathe. Pretty impressed with this saw. Not only is it handling the thickness of the material, but it's cutting pretty square. I'm pretty happy with that. Now the real question is, how hot is this thing getting? And the answer is, it really isn't. I can feel just a little bit of warmth in the gearbox, but the motor itself feels almost completely cool to the touch. Right over the brushes, I can feel a little bit of heat, but it's not excessive at all. I don't think I would recommend this, but we got away with it. I'll put this 5-inch diameter piece of material in my 5-inch 3-jaw chuck. I've got the jaws reversed here, and this is really about as far as I would want them sticking out. I did check, and they will clear my little shield down there, so I think we're going to get away with turning something this big without going up to the larger 4-jaw chuck and taking on that extra work. I'm going to use my bearing bump tool to get this thing centered. It is a little bit wobbly just because any error in the squareness of that face against the jaws is going to knock it slightly out of true. I'll just bring this in and push lightly against the piece. I don't have the jaws very tight. They're just enough to hold it, and I'll just work this in until I get even pressure all the way around, and it will straighten up the part in the chuck. The remaining texture in the sound there, I think, is just due to the piece not being completely round. With that pushed in at least to an average center position, we'll tighten the chuck down good and solid. We definitely do not want this piece flying out. Let's see how that spins. That looks good. Better than it was when we first chucked it up. Let me get a turning tool here with an aluminum insert. Let's start by facing it off. I don't really know how well this is held, so I'll just start out nice and easy and see how this goes. And the answer is it's going really well. This cut is not quite cleaning up, but I'll go ahead and finish it and then come back and make a second pass. And that cut is cleaning up. I don't have a cross feed on this lathe, so I'm just cranking this in by hand. And we'll just go nice and easy and get a nice even surface finish. Now, I don't really have any specific diameter dimension that I'm shooting for. I just want it to be pretty, so I'll turn off the outside of the extruded bar and stop short of feeding the tool into the chuck jaws. That would be a bad day. This is the bottom of the foot, so I could just leave it flat, but I'm going to go ahead and rotate my multi-fix tool holder around here so I can present the point of the tool. And I want to just cut a hollow in the bottom here. This is, I don't know, maybe 20 thou deep, no big deal. I just want a little bit of relief so that it won't rock on the concrete floor if it's sitting on a piece of sand or grit or something. So we'll just plunge in a little bit and push this to the center. Unfortunately, I can't reach all the way to the center with the tool post in that position because I run out of travel on the DRO scale, but I can just move it to another position, touch off, and finish the cut. There will be a little seam in the cut there that you can see, but you won't be able to see it when it's face down on the concrete floor. Put in a chamfer tool here and go ahead and put a nice chamfer on the edge, because chamfers. If you watch carefully here, you'll see me use a brush to clear the chips. And I think that is everything we have to do on this side. To turn the other side, we'll flip this around in the chuck, and this time we have a nice square edge to put against the chuck jaws. So this should come in nice and true without any extra effort. We do have the accumulated concentricity error of gripping it from one end with a 3-jaw chuck and then flipping it around and adding the error of gripping it again from the other end with the 3-jaw chuck. So I will come in with my bearing bump tool and just push this in and get it as concentric as possible. This is going to be down near the floor, so if the cuts don't line up perfectly, it's fine. It's not worth getting out the 4-jaw chuck and taking the extra time. I'm not going to start by facing this time. I'm going to start with the outside diameter and just turn that down and try to get it to match up. A smart guy would have set this up in the DRO so he knew exactly what diameter to turn to, but I didn't do that, so I'm just sort of guessing here. And that is going to be close enough. Remember, this is going to be down on the floor. Now we'll face it off, and that first cut isn't quite cleaning up, so I'll take just a little bit more. And yeah, that looks better. Should be able to clean this up in one pass. As you can see, that saw cut was pretty square. I'm pretty impressed with that little thing. I would like all of the feet to be the same length, so I actually started with the shortest of the pieces that I cut, just so that I could clean this one up and then use that as my dimension. And it looks like, yeah, we're about 21 thou under my target 3.5. That will be just fine. And it looks like we're about 13.5 thou under on the diameter. Now I do want a pocket in the top of this to hold the foot, just to keep it from sliding off. And I do care about the diameter, sort of, so I'll kind of line up my tool here with the edge and set the diameter on my DRO to the 5-inch diameter of this part, and that'll allow me to dial into an approximate diameter for cutting the hole in the top of this. I'm going to have about 100 thou clearance around the outside of the foot, so it doesn't have to be super precise, but I would like them all to fit the same. I'm just going to go about 50 thou deep here. The depth really doesn't matter. That was 25 thou on the first pass. I'll dig in and pull it back. I was originally planning to make these 100 thou deep, but now that I'm looking at it, 50 should be fine. If that thing's popping up in the air more than 50 thou, it deserves to escape from the feet. I'll just rotate the tool into a shallower angle so I can reach the center and just plow out the rest of this material. I do want a square edge on the recess so that the foot can't ride up over the edge with vibration, so I'll bring in a high-speed steel boring bar, touch off, and pull this out almost to diameter, and then we'll come back at the diameter and plunge in to clean up the shoulder. And that should be perfect. All we need is a chamfer, because chamfers. That's one foot complete. We've got our shallow recess in the bottom just so it sits level, and we get our nice recess with a square corner in the top to hold the foot. Now I just need to make 2 more exactly like it. To actually install these new riser feet under the grinder, I could just deadlift it and kick them under, but that's not practical for everybody, so I'll demonstrate how to do this with a toe jack. If you don't have a toe jack, it is a fantastic tool for moving machines. This one was pretty inexpensive. I just picked this one up on Amazon. I will throw a link down in the description if you're interested. You just get the toe of the jack under the machine and lift. Nice and simple. Of course, I don't have it quite high enough to get the foot out. I don't want to lift it any higher than I have to because I don't want to tilt the machine any more than I have to. It's pretty top heavy and I'm paranoid. We'll get the new foot on top of the new riser, get that under the bolt, get it pushed into the correct position here. And then just lower the jack. Now sometimes these jacks can be very finicky and these valves can be really touchy. The valve on this one's actually pretty good. I've been very pleasantly surprised. Just open it and let it down gently. We really don't want to drop anything. And that's one foot done. I don't know why I'm pushing on that. It's not going to go anywhere. The grinder's heavy if I didn't mention that earlier. We'll just go around and hit the other 2 corners as well. That's 2 down, and now we just have the heavy side left. There's not room back here for me and the camera, but I'm just doing the same thing. I've got the toe jack under that back corner, lifting it up. I'll slide the new riser foot underneath and set it gently down on top. That's it. I can go get rid of these pieces of very, very soft wood that should never have been used for this. Let's level this thing. Start by seeing where we are. Set this front to back, and yeah, we are still a little bit low in the back, not as much as we were. Let's see where we are side to side. Yeah, we're a little bit off there. We'll start by leveling it side to side because we can just adjust 1 foot to do that in isolation, and then we'll level it front to back using the remaining foot in the back. This should be the quickest way to get this done. Start by releasing the lock nut on the bottom here. We'll just loosen that and wind it back so it'll be out of the way. And then just adjust the bolt to bring it level. Now you can see the level on the screen, but I have to stand up to see it. So I will, I guess, practice my squats here. Just adjust it a little bit at a time. Check the level. And we're just trying to bring this level side to side. Just a tiny bit more. And that looks good enough to me. We shouldn't have to do anything else for side to side level, so I'll go ahead and lock the lock nut down so this won't move. And then we'll rotate the level to the front to back position and see where we are there. Now we should be closer than we were because I wisely decided to lower the right foot instead of raising the left foot. Or maybe I just got lucky, you'll never know. But we are closer than we were, so I will just do exactly the same thing. Make small adjustments to this one back foot, stand up, check the level, and repeat. And that looks close enough to me. So I'll go ahead and run the lock nut down here in the back. It should be that simple. Because this only has 3 feet, there's no twist or anything like that to deal with like you would have with a lathe. Let's just do a final check here and make sure everything is okay, assuming I can get out from behind the grinder. See side to side. That is just about as perfect as it gets. And front to back. I can live with that. As long as we're crawling around on the floor, there is one other thing about this machine that has been bothering me. When the saddle is all the way back, there is a section of the V-way back here that is unsupported by the base casting. And it is wet with oil. This has a pumped circulating oil system. And especially when this thing wasn't level, when it was tilted down in the back, the oil would run back along that way and drip on the floor. You can see there are some oil spots down here. I've wiped it up some, but I do not like oil on the floor. Now, the obvious solution is to throw down something like this. This is pig mat. This is a quilted material that absorbs an enormous amount of oil. These are great for cleaning up messes. They're great for throwing in the bottom of the chip pan on the lathe or any place where you need to clean up or absorb oil. But if I just throw this down on the concrete, it eventually will get saturated and it will still soak into the concrete. So I picked up some 1/8 size aluminum sheet pans. And these are perfect. I have one under the lead screw on my mill where it drips on the floor. And you can just cut a piece of pig mat to fit in this perfectly. And then just throw this on the floor wherever you have something that drips. And when it gets saturated, you can replace the pig mat or you can just leave it and let it fill with oil if you don't care. This came in a 2-pack, so I've got one for the other side with a piece of pig mat in that as well. And that will take care of that. I think that should take care of the settling problem. If the grinder sinks through the aluminum risers, I will be very, very impressed. As always, drawings for the parts I made today will be available on Patreon, and to those of you who are already patrons, thank you. You are the ones who make all of this possible. Thank you for watching.